right, we are going to finish up the year. Finish up the year with 9-3 day 2. Just a big plug and chug formula you got to figure out today. 9-3 day 2. We are going to be finding a confidence interval again. It's called a C prediction interval. All right, so given a linear regression equation, y hat equals mx plus b, which you found on Desmos yesterday, or given to you on Desmos yesterday, and given an x value, which we'll call x sub 0, we are going to create a C prediction interval for y. And I will show you what I'm talking about. So you've got yourself a scatter plot, and then you find your linear regression equation. We're going to be given an x sub 0 value. And normally we would just say algebra 1, well, we would predict that the corresponding y value would be right on that line. That's a good estimate. But for real, the chances of it landing exactly on that line, pretty slim. It could be anywhere a little bit greater or a little lower. And this is what we're going to find. We're going to find this prediction interval for y for a given confidence level. And remember, the more confident, the bigger the interval, the bigger range of numbers. The smaller the confidence level, the smaller the interval. So we're going to be finding this range of values here instead of just this one value. So to get that range of values, we're going to be taking the y value on the line, which we call y hat, and we're going to add and subtract the max error, which is the distance above or the distance below, giving us the interval, just like when we did confidence intervals a couple chapters back. Now, to calculate big E, it's a lot more challenging than it was back in those that chapter 6 or whatever it was. Here's your formula you're going to use. To calculate big E, you need the t-score for your confidence level multiplied by that SE value that we calculated yesterday, which was quite challenging. Then we've got this ugly square root coming. 1 plus 1 over the sample size, plus a fraction coming. That is n times the XO given value minus the average of all of your x's squared divided by n times the sum of the x value squared minus the sum of the x's squared. So it's just a great big plug and chug formula. And for our degrees, to use our T table, we need degrees of freedom. And because we've got two variables, the x and the y, our df is n minus 2. So here we go. We're going to do one example all the way through. Get rid of this. Okay, the example we are doing is number 20. Is number 20 on page 450, which does refer us back to number 12. And I don't have the book handy, but I have all the information. So I think the easiest way to approach these is to write down all of the values that you're going to need in the plug and chug. So make a list of them. So we need the T value. We need the SE value. We need the sample size. We need XO. We need X bar. We need the sum of the x's squared, and then we need the sum of the x so that we can square it. So I picked the T, the S, the N, XO, X bar, the sum of the x squareds, and the sum of x's that we are going to physically square when we type it in. So there it all is. Okay, so this problem, again, I don't have the book, but I do have all the data. Our confidence level is 90%. Our sample size is going to be 10. So I don't have my T table here either, and I know you guys know how to read it, but so then the degrees of freedom will be 8, because it's 10 minus 2. And the 90% confidence, and if you look that up on your T table, you're going to get a 1.860. The given X value that they want us to predict for in the problem is 45.1. So that's just a given piece of information. The rest of this all has to be calculated. So let's go through and redo the steps for yesterday. So I'm going to switch to Desmos. And I already have the table typed in. So let me get there. Tab, Desmos. Okay, so there's the 10 data values already typed in. And I do want you to show just the first and last lines. So we have X1, Y1. You guys only have 3 columns because in the graphing calculator, people have 4 because they have to do a little more work. Then you've got your residuals, which is the E1 column. So the first X value is 40.6. The first Y value is 26.2. The last is 50.8 and 19.5. So we'll go through now and calculate those residuals. So remember how we do that. We go down to Y2 and you say Y1 squiggle, which is under the full keyboard on the bottom row. And then it's the MX plus B. So it's M, but it's X1, so that it refers back to our table, plus B. And then at this point, all you need to do is hit the E1 plot, and it puts them in the table. And those are the numbers I want. So I want the 1.69 as the first residual. And the bottom one is 1.58. So then to get the SE value, which we'll calculate down here, you need the sum of those, the square each one of those residuals and add them up. So remember, we do that by coming down to line 3, getting the total, and we want E1 squared. So that's 32.419. And we divide by, formula says, what was it, n or n minus 2? N minus 2. So that will be 8. And if I do that, oh, dead battery. Oh, that one's not going to work for me. Got nothing. All right, let me crank through it on my on the garbage calculator here. Let me do right here. Let's go 32. Let me go back to square root. Square root 32.419 divided by 8. 2.013. So that's the hard part. That's the most time-consuming part, I think. Okay, now we need the average of the x's. So remember, your x's are in column 1. So I'll just go down to another line here and say mean of x1, 47.55. Then I want the total of the total of x1 squared on the inside, so it squares first and then totals them up. 22,716.29. And then I just want the sum of the x's. I think I can just back up over that squared. Oh, no. Oh, did. $475.5. Okay, that's everything we need. So I will stop presenting, come back, and again, it's just a big calculator line. So everything is here. So to calculate big E, just following the formula that's on my other page. It's the t value multiplied by the SE. And you got that big square root coming. 1 plus 1 over n plus, now a fraction, 10 times the XO, 45.1 minus the X bar squared over 10 times 22,716.29 minus this one squared. Don't forget you have to square this one. That goes right up there. And then it's just a big calculator line. It may take you a couple tries to figure out what you have to do here. So if you do all of this correctly, you should get an E value of 4.026. So now to do our prediction interval, we need the y hat value for the 45.01. And then we will be adding and subtracting the 4.026. So to get this, we need the y hat equation, which I didn't write down, but it should, I wonder if I got rid of it. Forgot I needed to write it down. Let's go back and see if I have it there. Oh, it's still here. It's right where you do the Y squiggle thing. It is, M was negative 0.6459 X1 plus 50.7341. That's in that same box where we got the E1 residuals plot. And now I just have to plug the 45.01 in here. to see what that value, that y value is. So if you want to see me do that, I will switch this back to present again. So here's where I got that right back here on the second tab. Right here, you just plug in the m value and the b value up here into the linear equation. So now I am going to type in -0.6459 times my 45.1 plus b value was 50.7341. There it is. So that came out 21.604 plus or minus 4.026. So we expect the y value to fall in between these two results. So I can add, I'll write in my head, that's a 10, that's a 3, that's a 6. And then I just have to subtract 21.604 minus the 4.026. And I'll be done. $17.578. There it is.